Hello everyone, in this video I'll talk about Arduino UNO R3 board in a more detailed manner, and I'll also talk about some important technical specifications. So let us get started. You can see in the screen there are three images. Among these three images, these two, this one and this one, they are the same image that is the schematic image of Arduino UNO R3 board, and this image, this one is the image of a real Arduino UNO R3 board. Okay, so within this board you can see here there is a chip. So this processor, this microcontroller is the Arduino Atmega 328P processor, and this is the brain of this board. Okay, you can see here there is a USB type B connector. Okay, this USB B connector, type B connector, is connected to your PC. Okay, there is an alternative power up provision. This is a barrel jack, to power up this board. Here there is a voltage stabilizer. Okay, then this is the crystal oscillator which creates clock pulses. This is the 16U2 processor, Atmega 16U2 processor. So there are two ICSP header. You can see this one and this one. These ICSP headers are for uploading or in-system programming or in-system debugging of this chip. So this ICSP header is for this chip, that is programming the Atmega 328P processor, and this one, this ICSP header is for this chip. Okay, now you can see there is, there are two LEDs here. One is this one, the other one is this one and this one. So this is the RX LED, this is the reception LED, this is the transmission LED. TX is for transmission, RX for reception. So whenever this board is receiving any data, that means if the data transfer is from the PC to the board, at that time this RX LED will blink, this one. And whenever there is data transfer from this board to the PC, then the TX or transmission LED will blink. Okay, there is one more LED here. You can see the L, it is written as L. This LED is internally connected to pin number 13. Okay, and you can basically look at these two images also. There are many details that have been given in these two images. You can see there are 14 digital pins, sorry. So from 0 to 13. So there are 14 digital input output pins. You can see here this. Okay, this is a ground pin. Okay, then there are 6 analog input pins. So your sensors are generally connected to this, any one of these analog pins. Okay, these are power pins. Okay, and this is the reset button. You can see here, this is the reset button. At any point of time, if the board is not working properly, you can just press this button and the board will restart and it will start all over again from the beginning. Okay, and also you can see there are 6 PWM pins. You can see pin number 3, 5, 6, 9, 10, 11. These 6 pins are PWM enabled pins. So you can see right at the left hand side of 3, 5, 6, 9, 10, 11, there is a tilde sign. You can see this tilde sign, tilde sign, tilde sign, tilde sign. So whenever you see this tilde sign, so you will know that that particular pin is PWM enabled pin. Now more details. Okay, so I have already told you that this is the USB connector, USB type B connector, and this is connected to your PC. Okay, this is connected to your PC. Now what is the usage of this USB port? See, this USB port, it basically serves two main purpose. One is for power. You need to power up this board. So this USB port actually, and if you connect this USB port to the PC, so PC provides all the power to run this board through this USB connector. So one is to power up the board. The other one is for data transfer. Data transfer. So that means if there is any data transfer between the board and the PC, whatever data transfer happens, it will happen through this through this USB port. Okay, now this barrel jack, as I told you, this is an alternative power provision that I'll come later, but now we shall concentrate a bit more on this one. Now you see you have this one has actually serial interface. That means it has serial pins, and your PC has USB. So I write here, it has USB pins. Okay, USB pins. It does not have serial pins, whereas your Atmega 328P processor, 328P processor, it has serial pins. So I write here serial pins. Now how they will communicate, how the this 328P chip will communicate with the PC, because it is USB and this is serial pins. So they are not compatible with each other, so they cannot talk with each other. So then how they communicate? They communicate with the help of this chip, which is 16U2 processor, Atmega 16U2 processor. This is 16U2 processor. So it has, what it has is, it has USB at one end and serial at the other end, serial pins. Now see, this serial is compatible with these serial pins, so just simply connect these, and this USB is compatible with this USB, so connect them. So now what happens is, now your PC can talk to or establish a communication between PC and the 328P processor, that means the board. Okay, so this is the purpose of this this 16U2 processor. So 16U2 processor, actually how it helps, in this chip there is a bootloader. There is a bootloader. Okay, so why this bootloader is required? This bootloader is required to upload the sketch or the code, whatever you write in the Arduino IDE. If you want to upload that code from the PC to this chip, then this bootloader helps. And it happens through this 16U2 processor, as I have already explained. Okay, so the code, whatever you write, that goes through this USB port, then to this chip, then through the serial port, and when the code comes, actually it cannot just write randomly. So this bootloader actually helps to upload that sketch or code into this chip, that is 328p processor. Now this is the crystal oscillator, and what it does, it creates clock pulses. Now why these clock pulses are required? These clock pulses, this microcontroller, they actually executes a lot of instructions. So to execute those instructions, they need clock pulses, and without those clock pulses, they cannot execute the instruction. So actually these clock pulses helps in executing those instructions. So this is very important. That is why this clock pulses are required, and that is why this crystal oscillator. Now why this ICSP header? That I have already mentioned, that ICSP header is for uploading the code. See, what happens is, suppose somehow this chip is damaged or burnt out, and also this USB port is damaged. So at that time, what happens? How you upload the code from the PC to this chip? So that time you use this ICSP header. With the help of this ICSP header, you can upload the sketch or the code to this chip, even though this 16U2 processor or the USB port, they are damaged or burnt out. Okay. Now the other point is that what happens if this USB port is, if it is, I told you this USB port is used to power up this board. So what happens if this USB port is damaged? So there are alternative provisions. So through this barrel jack also you can power up this board, and also you can see here one pin, that is V in pin. So apply 5 volt here. So in this manner also, even if this barrel jack and this one, they both are damaged, so if you apply 5 volt here, in that manner also you can power up this board. You can also power up this board through these 2 pins. You can see here 5 volt and 3.3 volt. Actually they are output pins. That means you can take out 3.3 volt or 5 volt, but you can also use them as input, but it is recommended that you do not use these 2 pins as input pins. You use them only as output pins. Okay. So there are in total 3 solid ways through which you can power up this board. One is through this pin, through this barrel jack, through this USB port. Any one of them is fine. Okay. Now I told you there is RX, there is a reception LED, there is a transmission LED, which indicates the data is being transferred from and to between the this Arduino board and your PC. Okay. Now this one, there is one on LED, so this will remain on, or it will just glow as long as your Arduino board is on. Okay. This LED will glow. Okay. And there is this LED which is internally connected to pin number 13. So there is one ground pin here. You can see there is one ground pin. And now some important features of Atmega 328p processor and 16U2 processor. You can see this one, Atmega 328p processor. So you can see this one, Atmega 328p processor. This is an 8-bit processor. Please remember this one. Memory is 32 kilobytes of flash memory, 2 kilobytes of SRAM. SRAM is for static RAM or simply RAM, and 1 kilobyte of EEPROM. Okay, and its operating frequency is 16 megahertz. Okay, I told you need clock pulses to run this chip. Okay, the operating frequency is 16 megahertz. And for security, there are two options in this chip. There is one is power on reset, and the other one is brownout detection, or brownout reset provision. These two provision is for security. If there is any malfunction or there is any anything wrong, then you can just use this provision. That is, one is power on reset, which is this one, you can see. So if you press this one, this whole board will start all over again. Now there are two 8-bit timer or counters. There is one 16-bit timer or counters, then one USART, that is serial port, one SPI port, the SPI interface, one dual mode controller or I2C interface, one analog comparator with a scalable reference input, then watchdog timer with separate on-chip oscillator, 6 PWM channels. Okay, you can see there are 6 pins. So see, these are just technical terms. You generally do not use like PWM pins. You do not use like analog to digital converter pins, ADC pins. You use PWM channels, you use ADC channels like this. Then internet and wake up on pin change. Okay, this is about Atmega 328P processor. Now I shall talk about this Atmega 16U2 processor, this one. You can see this is an 8-bit processor, RISC-based microcontroller. Okay, and its memory is like its working frequency, operating frequency is 16 megahertz, 16 kilobyte of ISP, that is in system programming or flash memory, then 512 bytes of EEPROM, then 512 bytes of SRAM or simply RAM, then debugware interface for on-chip debugging and programming. Now you see, this chip is basically, I told you, that is for in-system programming or in-system debugging. Now there are alternative methods, like some vendors, or some board manufacturer, they use generally FTDI chips or maybe JTAG interface. But in this case, the Arduino people, they use this 16U2 processor simply because this chip works fine, absolutely fine under resource constraint. Now you can see this board runs on USB powered from PC, so it's definitely not too much power. So in this power also, this chip 16U2 processor works absolutely fine. You can read a little bit about Atmega 16U2 processor, then brownout reset and power on reset. Okay, these are simple things. Okay, now you can see here there is a I'm talking about Atmega 328P processor, that means this one. Okay, now you can see there is one built-in LED that is connected to 13th pin, and that LED is this LED. Okay, this is internally connected to pin number 13. Okay, then digital input output pins, there are 14 digital input output pins. So you can see here, that is pin number 0 to 13. There are total 14 digital input. So these they all are digital input output pins. Now there are 6 analog input pins. So you can see A0 to A5, there are 6 pins. These are analog input pins and your sensors are connected to these pins. Okay, now PWM pins, there are 6 PWM pins. So wherever you see this tilde sign, so you will know that those pins are PWM pins, like 3, 5, 6, 9, 10, 11. Okay, now communication protocol, there are three communication protocol communication that this board supports. Okay, one is UART. So you can see these two UART, these are for serial communication. Then I2C, I2C is for this one. So these two pins are for I2C communication. So what is I2C? I2C is inter-integrated circuit communication. Okay, this is a simple two-way communication. So when you are dealing with complicated or bigger electronic circuits, you need to communicate between two devices or two chips. So at that time, this I2C communication protocol is used to communicate between two chips. Okay, now this SPI, this is these four pins for SPI communication. Okay, so what is SPI? SPI is serial peripheral interface. So this is synchronous serial communication. Okay, now power, you can see there is input voltage. So this one is the pin, this is the input pin V in, and that is 5 volt. This is the input pin. So you can power up the board by applying 5 volt to this pin. Then input voltage, which is nominal. So if you apply through this barrel jack, so the input voltage should be between, it is recommended to be between 7 to 12 volt, and after that it meets one voltage regulator, then it supplies 5 volt as output. Okay, then DC current input is 20 milliampere, and power supply connector, that is barrel plug or barrel jack, this one. Okay, then clock speed for this processor is 16 megahertz, and clock speed for this one is also 16 megahertz. Okay, then ATmega 328p memory for this chip, because memory you need to have the account of this memory. So that is, the total RAM is 2 kilobytes, total flash memory is 32 kilobyte, and EEPROM is 1 kilobyte. So this is about this one, this chip 328p. Okay, and there are two more pins, like you can see there is AREF or analog reference pin. So this what happens, it is used for analog to digital conversion. Okay, so this is just like a reference voltage, it works like a reference voltage. Now you see this one, this pins, so from PC you get 5 volt, but often it is not 5 volt, it is less than that. So if you do not use this A reference, then say it is 4.5 volt, it is not 5 volt, it is 4.5 volt for some reason. Now if you do not make use of this A reference pin, then what happens is, in the output of ADC you will get some error, which I'll talk about in detail. Okay, so so that is why what happens is, even though it is 4.5 through this USB, you can externally use 5 volt. Say by you measure something through by your multimeter, and you see that there is a 5 volt voltage source. You connect it to this pin, and it will work as a reference, and your board will convert analog to digital by referring to this voltage, which is 5 volt. But if you if you do not use, then it will convert using 4.5 volt, considering that this 4.5 volt is 5 volt, which is wrong in a way. I'll cover that. So this, you can see this input output reference. So you can see this pin on the Arduino board provides the voltage reference with which the microcontroller operates. Again, more or less the same thing. This is for input output reference. Okay, so that's all. I hope you have understood. So we shall meet again in the next video. Thank you.